Welcome, my friends! In order to add or subtract rational expressions, expressions that are the ratio of polynomials, we need to have a common denominator, and we usually use the least common denominator. Now, you might remember that the least common denominator is just the least common multiple of the denominators. So for example, if we had 2/5 and 4/9 that we would like to add together, we could list the multiples of 5 and 9 to find the least common multiple. We see that the smallest number in common to both lists is 45, which becomes the least common denominator, or LCD. That means we can modify each expression to get each term to have a denominator of 45 before we add them together. We would need to multiply 2 over 5 by 9 over 9 to get 18 over 45. And we would need to multiply 4 over 9 by 5 over 5 to get 20 over 45. Then we could proceed to add the two expressions together by adding the numerators, which would give us 38 over 45, which cannot be reduced. We can use a similar process for rational expressions. Say we have 3 over 5x minus 10 and 5x over 4x minus 8, and we want to find the least common denominator. Looking at the denominators, it might not be clear what the least common denominator is, but oftentimes factoring can help you see it a little bit better. If we factor out a 5 from the denominator of the first expression, we get 3 divided by 5 times x minus 2. We can factor out a 4 from the denominator of the second expression to get 2x divided by 4 times x minus 2. Now we notice the two denominators both have x minus 2 in common, and the only difference is the constant of 4 or 5. Our LCD will have x minus 2 in it, as that is common to both expressions. But we need to find a constant that is the least common multiple of 5 and 4. Here are the multiples of 5 and 4. We notice the smallest value in common to both lists is 20. So that means that our least common denominator must be 20 times what we already had in common between the two expressions, x minus 2. If we wanted to add or subtract these two expressions, we would need to get a denominator of 20 times x minus 2 on both of the terms. The actual adding or subtracting of rational expressions will be covered in a later video. In this video, we're just going to focus on finding the LCDs. Say that we have x over x minus 5 and 4x divided by x minus 3, and we want to find the least common denominator. In a case like this, where you have expressions on the denominator on x that can't be factored out and don't have anything in common, the least common denominator will just be the product of the denominators. So in this case, the least common denominator is simply x minus 5 times x minus 3. Let's try something slightly different. Say that we have negative 7 over x is equal to question mark divided by 3x to the 8th. We want to know what would have to go in the numerator of the right-hand side to make the two equations equal, which might be a single number or possibly an expression involving x. This is kind of like you've already figured out that the least common denominator is 3x to the 8th power, and now you want to multiply negative 7 over x by something so that it will have a denominator of 3x to the 8th. Ask yourself, what does the denominator of negative 7 over x already have that our blank over 3x to the 8th has? Well, of course, they already have an x in common. What negative 7 over x is missing is a 3 and an additional 7 x's. In other words, negative 7 over x is missing 3x to the 7th. What we end up needing to do is multiply negative 7 over x by 3x to the 7th divided by 3x to the 7th, which is, after all, just 1, and won't change the problem at all. This is a common manipulation in mathematics. Multiply an expression by something divided by itself, which will change the way the expression looks, but won't change the value, because anything divided by itself is just 1. This will leave us with negative 21x to the 7th divided by 3x to the 8th. At this point, we have found our answer. We modified negative 7 over x to have the desired denominator of 3x to the 8th, and found that the numerator needs to be negative 21x to the 7th, which is the missing value. What about 9 divided by 5x to the 6th is equal to question mark divided by 20x to the 7th? We need to find the blank so that the two expressions are equal. In other words, we want a denominator of 20x to the 7th, perhaps because that was the least common denominator in our problem, and we need to multiply 9 over 5x to the 6th in order to get that denominator. We ask ourselves, what would we need to multiply 5x to the 6th by in order to get 20x to the 7th? Well, to get 20, we would need to multiply by 4, and to get x to the 7th, we would need just one additional x, which means we need to multiply by 4x. Since we don't want to change our expression, we need to multiply by 4x over 4x, which is just a unique form of the number 1, and won't change the expression. We get 36x on the numerator and 20x to the 7th on the denominator. 36x is the question mark we needed in order to make the two expressions equal. Let's try 4 over x plus 5 is equal to question mark divided by x minus 1 times x plus 5. In this case, it should be clear that 4 over x plus 5 is missing an x minus 1, so we must multiply 4 over x plus 5 by x minus 1 over x minus 1. Distributing the numerator, we get 4x minus 4 over x minus 1 times x plus 5, so the question mark must be 4x minus 4. What about 8x divided by 8x minus 3 is equal to question mark divided by 40x minus 15? Let's factor the denominator on the blank, which might help us. We have 5 times 8x minus 3 as the denominator of the term on the right. Now it's clear that the only difference between the two denominators is that the second one is 5 times larger than the first. So we must multiply the first fraction by 5 over 5 to give us 40x divided by 5 times 8x minus 3. The missing value must be 40x. Alright, my friends, that completes our video discussing the least common denominator of rational expressions.